get now the first talk from Rob Wormald.
He does a good job of asking.
Oh yeah.
It means like small hill in English.
Oh,
It's not
here?
very interesting.
You don't like the translation.
So hey everybody, my name is Rob Wormald. I'm a developer program engineer at Google. I used to be a developer advocate up until about a week ago when I changed jobs. Being a DP at Google means I basically get to hang out with teams who are building stuff with Angular, help them out. That's what we're doing at KLM this week. So I more or less have the coolest job in the world. So I work at Google on the Angular core team. There's about 25 of us who work on the Angular core team, and about probably another 25 or so open source kind of main contributors to the Angular project. And so it's my job to deal with the core team and take planning from the core team out to developers and get feedback from developers and kind of bring that back to the core team. I was a software engineer for a long time. I did web development. I started in Angular. I started as an iOS developer, so I've done quite a lot in kind of various different fields of programming. I work on a project, or I started a project called NGRX. If you're an Angular developer, you've probably heard about this. I'm not going to sell it to you today. My name is so weird that I have the same address on pretty much all of the social media sites, so it's Rob Wormald. You can find me pretty much anywhere. A little bit of bookkeeping. I tend to get quite excited about this topic and tend to start talking very quickly and speaking very quickly. So if I do and you cannot understand what I'm saying, because that will happen, throw something at me, wave your hand, whatever, that's okay. If you have a question or a comment, feel free to shout it out. That's not going to bug me. I'd rather have a conversation than give you a lecture. So, any questions, please reach out and ask me. So normally in one of these talks, I would come up here and I would talk to you for 20 minutes about Angular and how awesome it is and how everything we do is great and it's going to make your life really easy. I'm not going to do that today because one, I've been doing that for pretty much 4 weeks straight and I want to talk about something different. The other thing is that some of you may not be Angular developers, you may not even be web developers, and so I don't want to kind of go 3 steps down the path without kind of showing you the basics of what we're doing. So quick survey, who is a web developer in this room? Would you consider web developers? So most of you. Who isn't a web developer? So who's a backend developer? Who's never written code in their life? Anybody? Awesome. So we're going to do something that this is going to be basically reactive programming, right? And again, I could stand here for 20 minutes and I could talk to you about the definition of reactive programming. It's an old term, it's not new, it's not really new to programming in general. This has been happening in Java for a long time, for example. It's happened in C++ for a long time. C# has this. This is not new. But we've kind of recently rediscovered it in front-end development. And Angular does a lot with it, but I want to show you kind of reactive programming in a nutshell, if you like. So without going too deeply into the definition, for me, reactive programming is basically programming with observables. And so this is a word that if you're a web developer may be new to you. Observables are just a type in JavaScript. They're a function that you can use to do some very, very interesting things. And again, I don't want to spend too much time kind of talking about them. I'd rather show you how they work. But in general, this is programming with observables. And in RxJS or in JavaScript, we use a library called RxJS. RxJS started at Microsoft. It was started by a team at Microsoft. It's now written by a team, or was written by a team at Netflix, the version that we currently use. So if you've used Netflix at all, pretty much all of Netflix is driven by RxJS. Their front-end web apps, their mobile apps are all using reactive programming in some fashion. So Netflix is really, really big on this. And we work really closely with both Microsoft and Netflix to develop the current version because we use a lot of this inside of Google as well. And so why do I care about this? Why is this something that I talk about? Why am I super, super excited about this? And really it's because asynchronous programming is really, really hard. If you're a web developer, you know this. This is not an easy thing to do. Complex web applications today, and even simple web applications today, there's a lot going on, right? You have users who are interacting with their applications. They're clicking and they're dragging and they're sliding. They're doing all these things. You're making web requests, you're going out to the server, you're fetching data, you're doing all of these things, right? You're talking to browser APIs like geolocation, or any of these things are kind of baked into the browser. You might be doing animation. All of these things are asynchronous, right? And if you're not a JavaScript developer, basically we have one thread in JavaScript, right? We have one place to run code. So I'm going to do something that takes a long time. I'm going to go talk to my server. If I don't do things asynchronously, my code stops, it blocks, and that means I can't do anything on the web, right? So this is not ideal. And so when this all started in the beginning of JavaScript, right, and this kind of started with callbacks, and callbacks are how JavaScript traditionally handles this asynchronous behavior. And basically it is what it says. A callback is start doing some work, right, and give me a call back when it's done. The problem with this, if you've written any kind of code in anger, is that you end up with code that starts to look like this. It goes left to right, right? We call this the callback pyramid of doom. And so it's a fairly good example of this here. So this is just a simple bit of JavaScript that basically, reads a directory, gets a list of files, and then does something with each of those files. So for each file, right, we're iterating over it. We get the file name, we get the size, we check the size of it, and you can see as we kind of go through the logic in our program, we start moving left to right. And this becomes quickly unreadable. It's always a good kind of clue that you're writing code like this when you see at the bottom here. You've got a bunch of brackets that kind of close, right? This code is pretty hard to maintain, pretty hard to do anything with. I find it very difficult to understand, very difficult to read. It becomes very difficult to debug. Now, if you're a web developer, and even if you're not a web developer, why do you think this code occurs this way? Why does this code have to be written this way? I look at this, and the problem with this code is that it's all designed around time, basically. And what I mean is, you start with this function, right? We do something, we give it some arguments. So we say, I want you to go read this directory. And then this is that callback, right? This is that thing that says, okay, that work is done. Here's the stuff you asked for. Let's do the next thing, right? And so you end up basically nesting all of these calls, right? And it's because, basically, you have to wait for, if you like, the right time, the right space to do this work, right? And you can't sort of represent the work that's happening as a thing. You can't get a hold of it, you can't deal with it, you can't actually kind of capture this time, right? You sort of have to basically be in the right place at the right time to handle this code, right? And so not too long ago, so 5+ years ago, promises came out. Promises are fairly new to JavaScript, they're very powerful, they've changed some things. If you've worked on Java or things like this, is also known as a feature in a lot of other languages, right? And what this gives you is a type, a thing you can carry around, an actual object that represents the work that's happening, right? I'm just going to switch over to code now because it's a little bit easier to demonstrate than trying to explain this as we go. Put this down as well. I'm going to yell a bit louder. Can everybody still hear me? Everybody hear? Good. Awesome. Cool. So I have a very, very simple project set up here. We've just got a couple of different files. I'm using TypeScript because everything I do in it is TypeScript. Mostly I'm using it here because it's going to get type completion, and I'm going to get IntelliSense. I'm not going to look stupid, not remembering what the method is in front of me, right? So just do a little bit simple code here. Just lost my code. Cool. So we're going to look at our main.ts. And what I want to do is basically I have a very simple setup here that's going to make a call to YouTube. I'm going to basically create a little type-ahead search box for YouTube. So I'm going to go out to the YouTube API, I'm going to make some searches, I'm going to search for cat videos or whatever, and kind of get a feel for how this works. So in the old days, and again, the old days in JavaScript is 2 years ago, the way that you would do this is you would create an XHR. So an XHR is just a XML HTTP request. It's how we talk to the server. So I create a new XML HTTP request. I assign some stuff to it, right? So I can say XHR, I can add an event listener. This is going to say, when this request is done, when I've gotten that data back from the server, go ahead and call this callback, right? So then we're going to say XHR, or I'm going to say add event listener. We can say when this, either the status changes or the load changes, and I'm going to do it this way. Do XHR.on. Load end, or on progress, or on ready state change. Any of these are sort of callbacks, right? So some function that fires when this work has happened. So I can say when this happens, go ahead and do something. And now we start that nesting problem, right? You can see that to be able to deal with this response that's coming back from my server, I have to be in this block of code, right? So I can log this out here. And then, we go on, and I do something like I actually add the address, and I go ahead and open this request, and I, send all this information I'm going to have to set up. And basically, I'm going to start this code running, and then the next piece of my logic is going to have to live in here. So this isn't ideal. A bunch of smart people got together. They invented promises, they invented fetch, and so now in JavaScript we can do it like this. So I can say the response, or I can say the request. I'm going to say basically do something like fetch. And then I have a little method here that's going to say, this is going to basically construct a URL that's going to talk to YouTube, and I can say something like, let's search for cats, right? And go ahead and what I have is a promise. So this is a request. It's a promise of the response, right? So this is an object that represents the eventual response. But this is a real thing. I can pass it around, I can hand it to other functions, I can wait for it. And what this means is now I've captured that sort of moment in time, right, as a real thing, and now I have a handle on it, and I can do whatever I want. So this makes the life much, much simpler. I can just call request.then, and then I get my data back. I can say data.json, so I'm parsing this JSON, and I'm going to go ahead and just then get results and console.log. This data. So with any luck, if we go ahead and clean this up slightly and run this in the browser, actually run that. Actually, I'll run the server to make this work. Running. Okay, so what you can see is I've made that request, I've gone up to the server, I've gone ahead and actually talked to YouTube. So that goes out to YouTube, it's this long kind of Google API's request, and then what I get back is, right, a list of data items, these are search results. So I've searched for cats, it's gotten me a list of data, right? Everybody kind of okay with where we're at so far? Pretty straightforward stuff. We've got a promise that returns our data, right? This is great. Now, promises made everything much better in JavaScript. They kind of, for a couple of years in JavaScript, solved our problems. Everything was great, right? But how many people in this room have a mobile phone, have a cell phone? All of you, right? Is your cell phone anywhere close to as powerful as your desktop computer? Probably not, right? And you're all paying for data, right? All of you are paying some company for every single byte that comes down the wire. And maybe not in a civilized country like Holland, but certainly in the United States, I pay for every single byte that I send over the wire, right? So promises are great, but they have a couple of problems. And the first thing is, a promise, once it starts, can't be stopped. It's going to do what it's going to do until we're done, right? And that's fine in this case where we're making one request and it's very simple. But if you think about what this looks like in a real application, so we'll wire this up and do something a little bit smarter here. So I've got a very simple text box in my HTML here, right? It's just got input. I'm going to query for it in my main file here. And then I can do the same thing I was doing, right? So I'm going to do search input dot, so why do you have to retype it? So, search input, that's just the done. I can say now add event listener. Anybody spot my error yet? There it goes. Okay. So, what I can say is when somebody types in the input box, right, we're going to get the actual text that's in the input box out. So I can say what I want is the length of the query. I can say event.target.value. So what I'm actually going to do is each time I type in the input box, I'm going to just log this value out. So, I've got a little search box here, and hopefully now as I type in this box, hello world, you can see it's actually going to write a lot of these out. So what I really want to do is, each time I type in the box, then I want to make this request, right? So I do a request. And what I actually want to search for, right, is that query. Request. We'll log that out. So we should see now, as I do something like search for cats, right, it's going to go ahead and fire this request out. It'll make a request for each letter that I type in the box. And this is kind of how pretty much every web application you've ever used works, right? What's the problem with this, though? As soon as I start typing the letter C, it makes a request, right? But as soon as I type the next letter, A, I don't care about the result of C, right? I don't care about this thing anymore. And now I'm wasting bytes. I'm wasting time, I'm wasting energy, I'm wasting battery power, because I'm waiting for requests I don't care about. And this gets even more complicated when you think that, okay, this is a Google API server, and it might actually take longer for the first request to complete than the second. And then my responses arrive out of order, and then my whole life goes to hell, right? And this is for one very, very simple form. Multiply this by, the dozens of text boxes that your average application has, and it becomes very, very unwieldy very, very quickly. And this is before we even get into the interesting stuff. And so really, beyond cancellation, I want to be able to say, for example, actually wait until I've typed 2 letters, right? Because there's no point in searching for the letter C on YouTube. There's nothing useful for that. So I can do something like this and get into my code, and I can say, okay, actually, only do this, like if the value of query dot length is great. And this gets boring as hell. It's awful, and it's very ad hoc, right? You get all these conditions. Your boss is going to come say to you next week, hey, actually, in this case, I want you to wait for 3 letters, and actually, we're going to wait for 2 letters in this case. And then, your code just gets worse and worse and worse and worse. It becomes totally unmaintainable, and everything is awful. So this is not great, but this is how everything is done today. So RxJS Reactive Programming is about trying to solve this problem. And so now I'm going to blow everybody's minds in 2 seconds with actually doing this in a really, really cool way that's very, very simple, and I hope kind of expresses to you how much fun this is and how much easier your life could actually be if you did everything this way. So I'm going to start with that same text box here, right, my search input. But what I'm going to do is bring in this observable type. So this is like using promise or observable. So observable comes from RxJS. So I'm going to grab the observable, and I'm going to say this. So what I want to get is const, a stream of these queries. So I'm going to say queries is equal to observable.from events, my search input, right? So these kind of are basically sort of equivalent. I had that add event listener, but what I've got now is basically an observable that represents that information I'm typing in the box. And so in the same way that a promise represents one eventual value, right, an observable represents many eventual values, right? 1 or many, greater than 1, greater than 0. So what I can say is now basically queries dot subscribe. So I want to listen to this query happening. I'm going to console.log that out. So this should work exactly the same. We're not going to make the request yet. Type in the box, and I get that data coming out, right? So what you can see is I'm actually getting the event here. What I care about is actually the value of the input box, right? It's that nested value. So what I want to do is, arrays. Everybody's used arrays or sets, things like this. Arrays have a really useful method called map, right? Map, reduce, filter. These are kind of basic, powerful JavaScript things. Observables have the exact same API. So we're going to start and say, what I want to do is for each value that comes down the pipe, right? Each time I type in the box, I want to transform, map that value. So I'm going to say map. This gets the event, and what I'm going to return is the event dot target that value. Right? That piece of the target value that I actually care about. Call this right? So what I'm saying is for each value that comes down the pipe, map it to something else, return something else, and then subscribe to it. Cool, so what we should see now is as I type in the box, right, we should see just the letters that we care about, right? So this is a transformation happening. One thing comes down the pipe, I do a very simple transform to it, I return it back, and my stream continues with the new values. Is everybody okay with this so far? Ish, yeah?
Yeah.
Okay, cool. So map is a very simple thing. It's a simple function, give it a value, and return the value, right? What we want to do is start mapping these things. So I'm getting this query here. Now what I want to do is actually turn each of these queries into that URL that I was sending to YouTube, right? So I have a very simple function, that make URL I was using earlier. So I'm going to say map again. So now I'm going to get the query string. That's the text that I'm logging right now. I'm going to say make URL with that, and pass in my query string. Now you can see as I type in the box, we're going to see that URL that we're going to send out to YouTube, right? So again, we've just done 2 maps. Each value is coming down the pipe. We transform it, and we carry on. So now what I really want to do here is take that URL that I've just constructed, right, and turn it into a request. And really what I want to do is turn it into a request and then turn that into a response, right? So we have map. Map does things synchronously. You give it a value, you synchronously return the value back. So Rx is a really useful operator called flat map. And so flat map works exactly the same as map, except that it waits for the thing to come back and then passes back the result of the value. I'll show you what I mean here. So now I've got my URL that I'm making the request with. I'm going to use Rx's built-in Ajax here. And so this is just like XHR, just like fetch that I showed you, except instead of using a callback or returning a promise, it returns an observable. So I'm going here. I can say ajax.get, I should say get JSON, my URL, right? So now what we hopefully should see is, as I type in the box here, it goes and makes a request, right? Each time I see the request, it waits, sends me back the actual data that's coming out. This is great, right? But I'm still actually wasting all that data. The results are going to come back in order, handle that problem for me. But actually, as you can see, as I type in the box here, so this is just the network log. You can see all the requests that are going out from the browser. Look at that. Hello world, right? So there's a ton of requests going out. And again, I'm still waiting for the response to come back. I'm transferring, what, like a K of data. That transferred 16K in 10K strokes. That's like $25 in the US of data, right? That's a lot. So really what I want to express is when and if, right, I send a new value down the pipe, forget about the old value, cancel it, I don't care about it, and hopefully cancel the request under the hood, right? So I'm going to change this just slightly to the thing called switch map. So switch map is baked in, it's exactly like flat map, except that if a new value comes down the pipe, it will cancel the previous request for me. It'll throw it away, it'll ignore it, I don't have to worry about it. And if I do this quickly enough, hopefully, you should be able to see this happen in real time. So as I do CATS, you'll see it actually manages to cancel those requests, right? So the request goes out, I throw everything in, cancel it, and now we're saving data, right? So that was 1.7K in the same kind of string of data, right? It's a big deal, it's a big thing. And again, it took, what, 2 lines of code, 3 lines of code? So this is kind of the way we think about reactive programming, right? You start with, what's the input to this system? What am I expressing to my application? In this case, it's me typing in an input box. And we just transform it. We just turn it into the output we care about, right? And I said that your boss is going to come to you and say, hey, actually, could we wait until we type 2 characters before we do anything? Here's how easy this is with RxJS, right? So arrays have filter. Observable has filter as well. So I can say filter. And what I'm going to say is basically, if the text dot value, text dot length, is greater than 1, emit it. Otherwise, don't. Just don't send it down the pipe, right? So now you'll see, hopefully, the first time I type in the box, C, nothing happens. Then A happens, and then the request goes out. Right? So what you're allowed to do is then really compose very, very simple streams. We call these just flows or streams that express input and do output. Right? Just to close the loop for you here, so really at the end of the application, what you really want to do is render this list of results, right? So I'm just going to create a simple function here. We're going to call this render list. That's going to take the results. For each, what we're going to do is return a results. For each result, we're just going to map that result into a UL. Don't ever do this in real life, but whatever. Okay. Right. Don't tell me that I did this. So I'm just going to put it here and say the results. Okay, the clever thing here, right? This is nice about TypeScript. So if we look at these little data objects that I'm getting back here, they're like 14 levels deep before I actually get to the snippet of the title that I really want to show you, right? And I would spend 15 minutes like changing the dots and saving it, and it's terrible, right? So actually what's really cool about this is I've got all this typed. I'm using TypeScript, right? So I just go here and say, what's going to come back from my make URL query here is YouTube response. So now, hopefully, I get my response back. That response, should be able to key off of it, right? I get items, I get all of the kind of typed information that I want. So what I'm going to say is my YouTube response. And what I'm actually going to do here is take one more map, right? So I'm going to map the response that's coming back. I'm going to say, actually, what I really care about here is the response.items. That's the actual list of data, right? So now when I get down here, I get items. That should be typed properly. It is good. Now I can go into my results. I can say basically, this is a YouTube video. I got So I'm using TypeScript just to make my life a little bit easier. Now I know what the type of result is, and I can say result dot snippet dot title. I should change those to LIs, not ULs, because I'm a real web developer. I know what I'm doing. And I basically just want to join those together with that string. And then, actually, let's just do this. So, take my render list. We're going to just run it through one more map. In a real application, you want to be a little more efficient than calling map a dozen times like I'm doing here, but this is easy enough for this case. And then I think the last thing we need to do is just go into our index here, create UL. Results. Yes. Look at our outputs. What did I call that thing? I already forgot. Thank you. Cool. And that's what I'm going to say is when the items come in, we're going to say results. HTML. Clearly I'm getting tired here. Output. So output inner HTML equals our items. Bets on that this is actually going to work the first time. Let's see. So we're going to search for cats. Oh, it actually works the first time. So we can say cats or dogs. And right, so now we've expressed a pretty complicated flow here. This is like the same way that this is actually the exact same way that Google's homepage search works. So type ahead, right, you get results. I could, and I'd probably get fired if I showed you the code that runs the Google homepage search, and I can tell you that it's significantly more complicated than these 6 lines of code. So that's kind of the whole spiel in the sense that like that's about all I can teach you in 15 or 20 minutes. But conceptually, this is a very, very powerful topic. And when we start talking about reactive programming and why I travel around the world talking about reactive programming is that this is a complicated thing, but we've made it pretty easy. And what this allows you to do is take this same pattern, this same observable type, and actually use it in almost anything in your application. So in Angular, now I'll give you the sales pitch. Angular uses observables for events, we use it for the router, we use it for HTTP. Basically everything in Angular is observable based. So what that means is that if you learn this one thing, observable, then you understand in a lot of cases how most of Angular fits together. And in an Angular application, you do things like, as my router changes, that's a stream. I can say, okay, each time the router changes, let's go out to my server, get my list of friends or users or whatever, and render it. And so it allows you to understand this one concept, observables, and really apply it to almost everything in your application. And just for the sake of seeing what this looks like in a real application, I'll just go into NGRX, which is my little project here. Bigger, smaller. And so an example app like this, something like NGRX and Angular, you end up building applications that use this power in a very, very straightforward way. So this is like a sample application. It's like a quick browser thing. Actually, like this. And then all of your application code ends up looking like this. So this is the way we go out to the server and make calls. We're doing this same bit of code where we're saying, okay, let's take an action, we'll map it, we're going to debounce it. Anybody in this room ever written a debounce before? It's a nightmare, right? RxJS is one line of code. And all of your application then is described this way. So in this case, it's, I want to go search for books. We're going to debounce, and so only every couple of seconds to go out to the server, map the results back, do the payload thing. This is exactly the code that I was demonstrating for you here. So that's the whole spiel. I could do this for like 4 hours. I'm going to just stop now because I'll keep talking. If this is something that's interesting to you, come and talk to me. I'll be here the whole time. You come and chat with me about this. Otherwise, check out RxJS.com. Check out Angular.com. We talk a lot about this. Or Angular.io. We talk a lot about this. My friend Van Lesch works on RxJS. He works at Google, so Google his name, Van Lesch. He is an awesome person to listen to. And otherwise, thanks for listening. That's enough for me.